Okay. So if you don't have any questions, let's start, right? We can do our lecture like discussion, right? So then I will ask some questions from you, right? You can answer, right? You can actually answer through the microphone or chat. You can answer to the questions.
Recording in
Okay.
progress.
Today's topic is introduction to the operating systems. What is actually mean by operating system? What do you think? What is actually mean by operating system? Anyone? What is actually mean by operating system? Right? You do not need to give me the perfect definition, right? What is actually mean by operating system? Anyone? What is actually mean by operating system? Okay. Operating system, right? It is a category of system software, right? Keep in mind, it is category of system software. Right, there's a one answer. It says that interface between person and hardware. Okay, so there are a lot of definitions, right? So if you take operating system, it is a category of system software, right? Operating system basically manage all the resources of the computer, right? Keep in mind, operating system manage all the resources of the computer, right? Then operating system act as an interface between the software and different part of computer or computer hardware, right? So operating system act as interface between software and different part of computer or the computer hardware. Okay, this is about the operating system. Then it's fully integrated set of specialized programs and handle all the operations of the computer, right? If you take the operating system, it's a fully integrated set of specialized programs that handles all the operations of the computer. Okay. So can you give me some examples for the operating system? What are the operating systems you know? All of you are working with the operating systems. What are the operating systems? Sorry, I can't hear you.
Windows 10, like that.
Right. Windows is an operating system, right? There are different versions, maybe 10, right? Now 11, right? Likewise, there are different versions. So other than Windows, what are the operating systems actually you used?
Ubuntu.
Yes, good. Ubuntu is an operating system. Then Mac OS is another operating system. Right. These are the famous operating systems, right? Mac OS, Ubuntu, and Windows. Other than that, when you are using the mobile phones, what are the operating systems actually you are using?
Android, iOS.
That's right. Android and iOS also comes under the operating systems, right? So you know the operating systems, right? Okay, let's move to the next slide. When you are taking the operating system do several things, right? One is resource allocation, right? Operating system do resource allocation. Under that, time and the tools, right? Time and the tools. Let's take some example, right? So we can take a shop, right? We can take a shop. Okay. So for an example, we can take a toy shop, right? So there are a lot of toys, right? We can take a toy shop, right? In a toy shop, how we can do the resource allocation? In a toy shop, how we can do the resource allocation? So for an example, we can take a toy shop. In the toy shop, what are the resources we need to allocate? Any answers? Any answers? If you take a toy shop, or let's take something like supermarket, right? For toy shop, then what are the resources we need to allocate?
Stock management.
Sorry?
Stock management.
Right. So we have to do store management, right? Okay. So if you take the toy shop, right, there are different type of toys with different bags, right? We need to allocate space for each and every toys. That's right. Then other than that, what we need to allocate?
Employee management.
That's right. Employees we need to allocate, right? We need to have a manager, then we need to have and sales executives, right? We need to have cashier. Likewise, we need to allocate resources into the toy shop, right? So if we think toy shop, then resources allocation may be time and tools, right? Time means now supermarkets can operate from early morning to late night, right? So people need to go for the supermarket like shifts, right? So let's take in a supermarket there are 10 workers are there, right? We can say 5 workers, please come to the work from 8 a.m. to 2 p.m., right? So after that, other 5 workers, please come to the work from 5 a.m. to, 2 a.m. to, 2 p.m. to 10 p.m., right? Likewise, we can actually divide in the toy shop, right? Then tools. What are the tools need in the toy shop? For an example, if you take a cashier, right, we need to allocate a computer, right? Because cashier need to do the actually need to get the money, right? So we need to allocate a computer. If you take someone from cleaning staff, we need to allocate relevant tools, right? Likewise, in the operating systems also do resource allocation, right? According to the operating system under the resource allocation, it's allocate time and tools, right? For an example, right, that computer can run several threads or processes, right? So to smoothly run our operations, right, we need to allocate time, right? We need to give time for actually access to the each resources, right? Also, we need operate for the operating system, we need to actually allocate the tools. Then operating system, second one, making policies. One is safety, one is fairness, right? So let's take our example, toy shop, right? For toy shop, right, we can make in policies for the safety, right? We can actually decide certain policies for safety and policies for fairness, right? Fairness must be there. Actually, I think you can understand what is mean by the safety, what is mean by the fairness, what is mean by the fairness. According to the toy shop example, what do you think? What is mean by the fairness? What is mean by the fairness? Now, for an example, if you take two workers, right, we need to treat them fairly, right? So if we allocate someone for a 8-hour shift, also we need to give other workers a 8-hour shift, right? if there are several cashiers, right? If we actually give a computer for a one cashier, so we need to give uh, other type of other computers for the other cashiers also, right? There are different payment methods are there, but we need to ensure the fairness, right? Likewise, in the operating system, that is a really important concept, that is fairness, right? We need to actually implement the fairness, right? Otherwise, the, the, we cannot run smoothly, right? Otherwise, in the computer, we cannot do our work smoothly, right? We need to ensure the fairness, and especially in the operating system, right? In the policies, right? We have to make sure the safety. Then mitigate the complex working task, right? Sometimes actually we need to mitigate the complex working tasks, right? For an example, in the toy shop, right, we can divide works into the different uh, areas or sections and distribute it among the workers, right? Likewise, mitigate the complex working task, right? This is also need to be implemented in the operating systems, right? Under that, performance and optimization, right? Performance and optimization, right? So, you know, if it is a toy shop, right, we need to go and see, right, whether the work after the 6 months or 3 months, we need to evaluate the workers, right? How is their performance? Best or not? Likewise, they need to do the optimization, right? Need to do the optimization, right? So there are several people are working, right? We need to optimize their work. Likewise, right? Likewise, operating system do the resource allocation, then it's making policies, then it's mitigate the complex working task, right? Actually, I take the toy shop as example, right? Then it is clear to you, right? So under the resource allocation, operating system, right, need to consider the time allocation and the tool allocation. Then policies, fairness policy, safety policy. Then mitigate the complex working task means the performance and the optimization, right? So that is about the operating system. So if you have any question, please ask. I'm going to give you 1 minute, right? If you don't understand any concept or if you need any clarifications, please ask.
Recording stopped. Recording in progress.
Okay, let's move to the next slide. If you take a computer, computer have 2 modes of operations. One is kernel mode, or we can call it supervisor mode. Other mode is user mode, right? There are 2 modes of operations. First one is kernel mode, right? Second one is user mode. Okay, so first we can talk about the user mode, right? Only a subset of machine instruction is available. User mode delegate to system API to access hardware or memory, right? So if you have experience in working with Linux, right? You know, Linux have modes of operations, right? Sometimes you are in the user mode, right? Sometimes you need to go to the supervisor mode, right? To do several operations, right? User mode, right? Only a subset of machine instruction is available. User mode delegate to system API to access hardware or memory, right? In the system mode, actually in the system in user mode, right? If your computer or system in user mode, right? When operating system is running, right? A user applications, right? For example, text editor, right? Maybe a Microsoft Word document, maybe a Excel document, right? In the user mode, keep in mind, operating system is running a user application, right? Like text editor or a Word document or a Excel, right? So when we talk about the kernel mode, it's a complete access to all the hardware and execute any instructions the machine is capable of executing, right? Operating system is the most fundamental piece of software and run in kernel mode, right? Keep in mind, if you are run in the kernel mode, you have complete access to all hardware and execute any instructions in the machine, right? That means it gives you complete access to the memory and the input output, right? It gives you complete access to the memory and the input output, right? So if you are actually working in the kernel mode, right, you can deal with virtual memory, you can deal with device drivers, right? Likewise, you can do, you have complete access to the all the hardware and execute any instructions. So then why we need two mode of operations, kernel mode and user mode, right? We can actually have a kernel mode now. So we can access to the all the resources, all the hardware and instructions in the computer. Why we need to have a user mode? We can actually, if we have in the kernel mode, then there's no problem now. So complete access is there, right? If you are in the user mode, subset of machine instructions is available. If you are in the kernel mode, you can actually access to the all the hardware and execute any instructions. Then why we have two mode of operations, right? Rather having the user mode, only kernel mode is there, it is enough. Why we have two mode of operations? What is the reason? Any answer? Any answer? For security purposes, actually we have the user mode, right? So anyone doesn't have a good understanding about the computers, that means everyone can work with the computers, right? So not have good understanding about these hardwares and all those things, right? It is safe to work with the user mode, right? Then only subset of machine instruction is available, right? So he can do all the things, right? He can play games, right? Running applications, right? But he cannot do any changes to the hardware and for the instructions, right? So for security purposes, right, we have these two mode of operations, right? It is safe to use user mode rather than kernel mode, right? Then you cannot do changes into the hardware, right? then you cannot execute each and every instructions that machine is capable of executing, right? Likewise, there are two modes. Then if you take the operating system, right, it's high hardware complexity, then it's do the resource management, right? Then provide isolation and protection, right? If you take the operating system, high hardware complexity, it's do the resource management, provide isolation and protection, right? Up to this point, if you have any questions, please ask. I'm giving you 1 minute.
Recording stopped.
Excuse me, sir.
Yes.
සර් මේ දැන් අපි මොකක් හරි දෙයක් කොපි කරනකොට කම්පියුටර් එකට එතකොට ඒක ඒ වෙලාව වැඩ කරන්නේ මේ කර්නල් මෝඩ් එකද?
මට පැහැදිලි නෑ.
දැන් මේ අපි මොකක් හරි දෙයක් කම්පියුටර් එකට කොපි කරනවා කියන්නකො.
ඔව්.
එතකොට මේ හાર્ඩ් එකත් එක්කනේ මෙමරි ගනුදෙනු වෙන්නේ.
Yes, yes.
එතකොට මේ කර්නල් මෝඩ් එකේ නේද ඒක වෙන්නේ?
No, no, we do not need to go for the kernel mode, right? That is why we have operating system, right? So when you are doing some operation, now in the operating systems, right, there are several actually functions are there, right? Several procedures are there. Memory management is one part, right? File management is one part. Then what's happened? Is it okay? I am explaining in the English.
Okay, sir.
Then another part, you have this I/O management, right? All the things are there, right? Above that, that application software are run. Now you need to copy and paste some file from your pen drive to computer, right? Now you actually plug your pen drive, right? Now I/O management is working, right? So according to the input-output management, now operating system actually know that pen drive is connected, right? You know there are several device drivers, right? Through the device drivers, right? Now it's detected pen drive is actually plugged into the computer, right? Then you need to do a kind of operation, right? You need to copy your Word file and paste it into the your computer. Then what's happened? Now you request the service, right? You open the pen drive, then find out the folder, then find out the Word document or Excel file, then you click copy, right? Now in the application software side, you give the command, right? Now what's happened? Now how application software and operating system communicate? කොහොමද ඇත්තටම application software එකයි operating system එකයි communicate කරන්නේ? දැන් අපි දන්නවානේ application software එකක් තිබ්බොත් අපිට ගොඩක් දේවල් ඉල්ලන්න පුළුවන්, right? සමහරවිට අපි operating system එකෙන් ඉල්ලන්න ඕනේ memory management එකට යන දේ. දැන් උදාහරණයක් විදිහට මේකෙදි අපි file එක save කරනවා නම් memory manager එකට කියන්න ඕනේ. Or maybe we have to request input output. So how we can call from application software, we can do some type of operation. We need to inform it to the operating system. How we can do that? Any idea? There's something called system calls, right? Now through the system call, we can say that we need to save a file in the memory, right? Then you can actually through the operating system, you can call the memory manager. Then memory manager help you to save the file, right? First, it's need to take the file. Then it's need to find out the slot. right? Empty slot where you need to save your file, then you can save the file, right? Likewise, operating system actually manages the things, right? Through the system call, you can tell operating system, right? I am need this type of service, right? Actually, there are several services, right? Maybe memory management service, right? Through the system calls, you can take, right? පැහැදිලිද?
ඔව් සර්.
So I will, you ask, I will tell you how memory manager works, right? So once you request a file, you need to save a file, right? So operating system have the logical address, right? Then it send, operating system send logical addresses to the memory manager, right? Then memory manager has a separate table, right? In that table, in one side you have the logical address, other side you have the physical address. So once it's going to the memory manager actually knows what are the free slots and what are the slots occupied, right? So it's search for the free slots, and it's according to your logical address, it's find the some physical address space, and according to that, it will store the information. සරලව වෙන්නේ save කරන්න ඕන නම් ඉස්සෙල්ලාම operating system එකේ logical address එකක් තමයි වන්නේ. file එකේ logical address ටිකක් තමයි වන්නේ. මෙන්න මේ දේවල් ටික save කරන්න ඕන කියලා. memory manager එක දන්නවා හරියටම memory එකේ ඉතුරු වෙලා තියෙන්නේ කොහෙද, මොනවද පාවිච්චි කරලා තියෙන්නේ. ඒක අනුව එයාලා මොකද කරන්නේ, logical address එකට හරියන physical address එකක් තියාගන්නවා. ඒක එයාලා table එකක් විදිහට maintain කරනවා. මොකද operating system එක දන්නේ නැහැ memory manager එකේ කොහෙද හරියටම අපි එවනේවා save වෙන්නේ කියලා. එවන document save වෙන්නේ කියලා. එතකොට සිද්ධ වෙන්නේ operating system එකෙන් එවනවා logical address එකක්. ඒක අනුව memory manager එක හොයාගන්නවා කොච්චර ඉඩක් යනවද කියලා. ඒකල ඒකට අදාළ වෙන physical address එක යා map කරලා තියාගන්න. දැන් කොයි වෙලේ හරි operating system එකට ආයේ file එක open කරන්න ඕන නම් එයා දන්නේ නැහැ physical address එක. ඇත්තටම memory එකේ කොහෙද save වෙලා තියෙන්නේ කියලා. hard disk drive එකේද, solid state drive එකේද, මොන set එකේද කියන එක දන්නේ නැහැ. හැබැයි එයා දන්නවා logical address එක. So the operating system sends the logical address, then memory manager has the table, it's mapped with the logical address and find the physical address, then it will be gives you the file, right? That is how working.
Okay, sure. Thank you.
Recording in progress.
If you take the operating system, actually it's hide the hardware complexity. It's do the resource management, then provide isolation and protection, right? Hide hardware complexity, then do the resource management and provide isolation and protection. Then what is an operating system? Already we discussed. A simple operating system is an interface between the user and hardware, right? Simply you can say interface between the user and hardware, right? So earlier I will ask from you that actually one student gave the answer correctly, right? So operating system is a system software privilege access to the underlying hardware and manage hardware according to the predefined policies, right? You know now operating system is a system software privileges access to the underlying hardware and manage hardware according to the predefined policies, right? So we actually talk about two policies. I think you remember. One is the fairness, other one is the security, right? So likewise, there are predefined policies. Also ensure applications are protected from one another, right? This is ensure that applications are protected from one another. Then operating system is a software that manages the hardware and software resources and provide common service for the computer programs, right? Software that manages the hardware and software resources and provide common services for the computer programs, right? This is about the operating system. Here you can see in upper you can see the applications. Then you have the operating systems in the hardware, right? Maybe drives, then RAM, maybe keyboard, printer, and monitor, right? So you know application software work with different languages, right? Then if you take the hardware only can understand machine language, right? Hardware cannot understand programming languages like Java or C or any other programming language. But if you take the hardware, right, only understand machine language, that means ones and zeros, right? So now application software cannot actually do operations with the hardware, right? Because hardware only knows machine language, right? Hardware cannot actually do operations with the application, right? So that we need an operating system. I will take some simple example and explain it to you, right? Now you think there are two persons, right? One person A and person B. Person A can speak Japanese. Person B can speak German. Now what's happened? Can A and B communicate with each other? There are two persons. Person A can talk with can understand the Japanese language, right? If person B know the German language. Now can person A and B communicate or not? What do you think? There are two persons, right? Person A understand Japanese language. Person B understand German language. Now they need to communicate with each other about a kind of a work. Can they communicate with each other comfortably? What do you think?
Can't.
Can't, right? Yes. They cannot have a fruitful communication. So now what's happened? We need to hire someone, right, who knows both the Japanese and German, right? Someone who knows the Japanese and German, right? So what's happened? Person A talk to the translator, then translator translate it and tell it to the person B. Then person B want to communicate with person A. Person B need to talk with the translator, right? Translator need to translate it to the person A. Likewise, operating system act like this translator, right? Simply, it's act like translator, right? It can take any of the requests from the application and it will send to the hardware, and it also take the request from hardware and send it to the applications, right? Sometimes you will experience, right? Sometimes hardware can have interrupts, right? We can actually learn about the interrupts later. Sometimes when you are playing video games, right? I know that you are playing video games, right? Maybe Need for Speed, maybe Call of Duty, right? There are a lot of video games are there, right? Sometimes while you are playing, maybe interrupt occurs and comes a warning message, right? You are ran out of your memory, right? Or maybe you have a different type of warning messages, right? Your resolutions are not enough, right? Likewise, hardware also sometimes hardware also make request, right, to operating system to application software. So if you take operating system, it's perform basically two unrelated functions. One is operating system as an extended machine, right? Then operating system as a resource manager. Keep in mind, operating system perform basically two unrelated functions, right? Operating system as an extended machine, operating system as a resource manager. So let's talk about what is meant by operating system as an extended machine. Architecture of the computer is difficult to program. The architecture may be instruction set, memory, organizations, I/O and bus structure of most computers at the machine language level, right? Machine language level is primitive and ought to program especially for input and output, right? For an example, if an user need to copy data from the hard disk, right? User need to write program for above scenarios without having operating system, right? Then program will be difficult to write. Program will be hardware dependent, right? So keep in mind operating system as an extended machine, right? Now assume, right, there is no hardware, sorry, operating system, right? Only application softwares and hardware, right? So user actually need to copy data from hard disk drive, right? Similar to the earlier question, right? User need to copy data from hard disk drive. Then user need to write programs for above scenario without having an operating system, right? Then program will be really difficult to write. Then program will be hardware dependent, right? Program will be only hardware dependent, right? So you have to actually write program again and again, right? Why? It will be hardware dependent, right? To save, you have to write one program, right? To retrieve a file, you have to write another program, right? Likewise, you have to run separate programs and it will be difficult to write. Now, actually think you don't have operating system and you only have application software and hardware, right? Keep in mind these instruction set, memory organization, I/O, bus structure, this architecture, most computed at the machine language level, right? They only understand ones and zeros, right? So, but somehow you need to write the code for the hardware, right? To save your file, right? Then it is really difficult. So actually we assume that you need to write this code. So what are the things you need to be considered? You need to consider there's no operating system, right? If you have operating systems, things are easy. So click save. You can select the CDOE drive, create a folder. That under that folder you can save. Now you don't have that luxury, right? Because you don't have an operating system. If someone asks you, there's no operating system on the application software and the hardware, then how you can write the program? First, you need to know the length of the file, right? Then you need to know what are the free available memory slots, right? There are several memory slots. You need to know what are the available memory slots and their memory addresses. Then you have to write the program, right? Okay, save this program in these memory locations or memory slots, right? It's really difficult. Writing also difficult. Then it will be hardware dependent, right? If you have operating system, you do not need to worry about any of the things, right? So you can save it, right? You can save any kind of document, maybe Excel, Word. You do not need to write code again and again. But if you don't have operating system, then it will be hardware dependent. right? Then, so a voice scenario has an operating system. It provides basic command or instructions to fulfill different operations such as reading, writing, save, close. Give a present beautiful interface for the users, and user don't need to program storage devices, right? So operating system act as extended machine. What's happened? Operating system provide commands and instructions to fulfill different operations such as reading, writing, and save, close. Give a present beautiful interface for the users, and user don't need to program storage devices. Then providing clean, abstract set of resources instead of messy hardware to application programmers and managing these hardware resources, right? It's providing clean, abstract set of resources instead of messy hardware to application programmers and managing the hardware resources. Then operating system real customers are the application program. Deal directly with the operating system and its abstraction. Then end user deals with the abstraction provided by the user interface, either command line interface or graphical interface, right? End users actually deal with the abstraction provided by user interface, either command line interface or graphical interface, right? Now, actually, in your computers, you are using the graphical interface, right? In left bottom of the left side on your computer, you can see the menu, right? In the desktop, you can see several icons, my computer, then different folders, right? So it's a graphical interface, right? So, you know, sometimes through the entering the commands, different commands, right? We can use the command line interface, right? Go to your search bar and type CMD and press enter. Then you can see the command line for the Windows, right? Likewise, abstraction provided by the user interface. Then operating system as a resource manager. Operating system as a resource manager. Modern computers consist of processor, memories, timers, disk, mice, network interfaces, printers, and wide variety of other devices. Operating system is responsible for managing all the resources. Modern operating system allows multiple programs run at the same time. If multiple programs running, there is need of managing and protecting the memory, I/O, and other devices and other resources. Right? Then if you take the resource management includes multiplexing. That means sharing resources in two different ways, right? We can say multiplexing resources. That means sharing resources in two different ways. One is time, other one is space, right? You can say time multiplexing or sharing, or space sharing or multiplexing, right? Time means resources is time multiplex. Different programs or users take turn using the time. First, one of them gets to use the resource, then another, so on. Print different documents, right? For an example, for this time multiplexing, right, or time sharing, it's the printer, right? In the printer, actually, we can say print different documents, right? Sometimes we have 4 or 5 documents. So we need to print each of the documents, right? So we do not need to go and print one by one, right? So we can say, right, print these documents, right? Maybe if your printer connected to a network, right, maybe 2 or more people actually request to print documents, right? So print different documents, right? Likewise. Then space. Instead of customers taking turns, each one get part of the resource, right? Main memory divided into several running programs, right? Space means instead of customers taking turns, each one get part of the resources, right? For an example, main memory divided into several running programs, right? Then these are, right? So I think you can understand, right? So for brief, right? Basically two unrelated functions. One is extended machine, right? Other one is as a resource manager, right? Resource management include resources in two different ways. One is time, other one is space. Okay, I am giving you 1 or 2 minutes. If you have any question, please ask.
Recording stopped.
This is a theoretical subject, but please learn this theory still, right? The important thing is understanding the theory, right? Because after finishing your degree, you are going to the industry, right? When you are going to the industry, you have different jobs opportunities, right? Maybe software engineer, right? In the software engineering side, maybe you have to develop web development side. You can go for the mobile development side, right? Maybe you are become a full stack developer, or maybe you are going for a like a network engineer, right? Maybe, right? Likewise, security engineer. Likewise, there are several job roles, right? Several job roles. So, if you are actually working like for an example, right? Like a mobile developer, right? It is beneficial if you know these operating systems well, right? About the threads, okay? About the hardware, right? Because then you are become a really good developer or a software engineer, right? Because you know how to code and you know about the hardware, right? You know about the operating systems, right? And functions. Then it's really easy for you to become a good developer, right? So, so that, right? Please understand the concepts, right? That's the important thing in the operating system, right? You need to understand the concepts, right? Concepts. If you don't, if you really understand the concepts, right, it will help you, right? It will beneficial you when you are going for the industry, right? As a developer, maybe a network engineer, whatever positions you are going, right? These concepts help you to become a good developer, right? So, in my lectures, anytime you can ask questions, right? Through the chat, through the microphone, right? If you have any question, please ask. And I have another announcement. I think today's you don't have the data structures lecture, right? Data structures lecture is not conducted today. Okay. So let's go move to the next slide.
Recording in progress.
10 type of operating systems, right? There are desktop operating systems, embedded operating systems, and the server operating systems. Any example for the server operating system? Desktop, you know, already you know, Windows XP, Windows Vista, Windows 7, Unix, maybe Mac OS, then Linux. Then server operating systems.
Windows Server OS.
Sorry, I can't hear you.
Windows Server OS.
Right, Windows Server OS. What are the versions?
2007.
right? 2012 is there, right? Likewise, different versions are there. Not only Windows, right? If you take the Ubuntu, right? Fedora, right? There are different type of versions support for the server operating system, right? Then embedded operating system, you already know, Android, iOS, desktop operating systems, you are really familiar, right? Then purpose and goal of the operating system. The purpose of an operating system is to provide an environment which a user can execute program in a convenient and efficient manner, right? Provide environment which user can execute program in convenient and efficient manner. Then goals of operating systems are use the computer hardware efficiently, then make the computer system convenient to use, to control and execute user applications and the programs, right? Simple, right? Use the computer hardware efficiently, then make the computer system convenient to use and to control and execute user applications and the programs. So let's see, right? There are different types of operating systems, right? Mainframe operating systems, server operating systems, multiprocessor operating systems, embedded operating systems, server node operating system, real-time operating system, right? Simply we can say operating system soup, right? So we can talk one by one, right? Mainframe operating system. Majorly cooperate in data centers, computers, different from personal computers in terms of their input-output capacity. Mainframes are heavily oriented with processing many jobs at once, right? This offers three kinds of services, right? If you take a mainframe, right, operate in data centers, right? Then computer in terms, right? They have different from personal computers because terms of their input-output capacity, right? Why we need this mainframe operating systems? Mainframes are heavily oriented with the processing many jobs at once, right? Then it's offer three kinds of services. One is batch service, other one is transaction processing, other one is time sharing system. Batch processing means process routine jobs without any interactive user present, right? Then something like sales reporting for a chain of stores. Then transaction processing, handle large number of small requests, right? For an example, check processing at an airline or bank reservations, right? Maybe used for transaction processing, right? Handle large number of smaller requests. If you take the batch service, process routine jobs without any interactive user present. Then time sharing system. Time sharing system means allow multiple users to run jobs on the computer at once, right? Allow multiple users to run jobs on the computer at once, right? We actually talk about this time sharing, right? Also, allow multiple users to run jobs on the computer at once. Then server operating system. Server operating system run on servers, which are very large personal computers, workstation or mainframes. Multiple users at once over a network and allow the users to share hardware and software resources. Server can provide print service, file service, or web service, right? To take the server operating systems run on servers, which are very large personal computers, workstations, or even mainframes, right? Multiple users at once over a network and allow the users to share hardware and software resources, right? Then multiple users actually allow at once in the network, and also for users share the hardware and software resources. Server can print services, file services, or web services, right? Print services, file services, or web services. Then multiprocessor operating system, right? Multiprocessor operating system. Use two or more operating system within a single computer system, right? Use two or more operating systems within a single computer system. Depending on how they connected and what they are shared, these systems are called parallel computers, multi-computers, or multiprocessors. They need special operating systems. These are variations on server operating systems with special feature for communication, connectivity, and consistency, right? So it's simple, right? Two or more operating systems within the single computer. You can say multiprocessor operating systems, right? So how they connected and what they share, right? These systems called parallel computers, right? Multi-computers or multi-processors, right? They need special operating systems, right? Variations on server operating system with special features for communication, connectivity, and consistency. Then embedded operating system. Embedded systems that run on computer that control devices are not generally thought of as computers, which do not accept user installed software, right? For example, microwave ovens, TV sets, cars, DVD recorders, right? We can actually use the embedded operating systems, right? That run on computers that control devices are not generally thought of as computers, which do not accept user installed software, right? If you take a microwave oven, TV set, actually you are not going to install the software. What you are doing is, there are predefined functions, right? If you take a microwave oven, DVD recorders, there are predefined functions, and there are embedded operating systems. According to that, you can work with the microwave ovens, TV set, cars, and the DVD recorders. But if you take a normal computer, right, you can install the software, right? You can decide several functions, what to do, right? But embedded operating systems are different, right? So, likewise, embedded operating systems are there. Then server node operating systems, right? Sorry, sensor node operating system. Sorry, not server, sensor node operating systems. Tiny sensor nodes are being deployed for different purposes. These nodes are tiny computers that communicate with each other, and base station is wireless communication to detect fire in forest, enemy movements. Sensors are small battery powered. Computers built with radios. Operating system has to be small and simple because node has little RAM and battery lifetime is major issue. Tiny OS is a well-known operating system, right? Then there are sensor node operating systems, right? Keep in mind, right? Sometimes, now you know, if you take an office, if you take the university, if you take your home, you have good infrastructure, right? If you want to connect it to the internet, right, you have several facilities, right? So you can use in the routers, right? You can use in fiber optical cables, right? Because you have well set infrastructure. But think something like this. Now you need to do, you need to monitor wildlife management. Think there is a forest, right? So you need to manage the forest, right? Several functions are there, right? Maybe you need to know about the animals of the forest. You need to detect the animals of the forest. Sometimes you need to detect the fire or flood in the forest, right? Okay. So in these type of scenarios, you do not have proper infrastructure. You know, there's a forest, right? Actually, we do not have network cables, right? We do not have good connections, right? So sensor nodes are being deployed for different purposes, right? Nodes are tiny computers that communicate with each other. If you take these type of scenarios, right, we are using actually tiny computers, right? These computers actually can communicate with each other, and base station is wireless communication. Detects fires in forest, enemy movements, right? Sensors are small battery-powered computers built with radios, right? Operating system has to be small, right? If you actually you need to have an operating system in these small computers, but keep in mind, operating system has to be small and simple because node has little RAM and battery lifetime is a major issue, right? Now, when you are dealing with different devices, right? If you have a computer, you do not actually need to think about the RAM and ROM, right? Actually, we need to think. We need to have a fast performance, anything. But basically, we are not thinking, right? Because we have 1 TB of hard disk drives, right? Maybe 512 GB of SSD or 256 GB of SSDs are there, right? So likewise, we have a lot of facilities in our computers, laptops, right? Even though in our mobile phones, right, we can insert a memory card and right, we can extend the capacity. But if you take devices like these, right, it is operating system has to be small and simple, right? Because only it has little RAM and battery lifetime, right? This is a major issue, right? For an example, TinyOS is a well-known operating system. Then real-time operating systems.
Excuse me, sir.
Yes.
Sir, මේ Raspberry Pi කියන්නේ අර sensor node එකට OS එකක්ද?
Raspberry Pi also, yes, we can take Raspberry Pi, but in the Raspberry Pi, we have a kind of difficulties, right? Actually, we can, Raspberry Pi, we can install easily, small in size, all the things are there, but how we can power the Raspberry Pi? Can you understand me?
Sorry, sir.
Raspberry Pi එක ගත්තොත් කියන එක හරි. ඒක tiny little ඊට පස්සේ අපිට ඒකට memory card එකක් Raspberry Pi එකට insert කරලා operating system එකක් insert කරන්න පුළුවන්. Functions කරන්න පුළුවන්. IO pins තියෙනවා, several pins තියෙනවා, right? But we can install OS, right? So but we have to think about the power. How we can power the Raspberry Pi?
Picking වෙන්නේ
Sorry?
Picking වෙන power supply එකක් නෙමෙයි.
Heating means power supply එකක් තියෙනවා, right? So ඒක හරි. Raspberry Pi වගේ ඒවා අපි use කරනවා. ඒත් අපි දැන් real world scenario එකට ආපුවම අපි සාමාන්‍යයෙන් කරන්නේ දැන් මේ වගේ devices අපි customize කරලා specifically හදනවා. විශේෂයෙන්ම හදලා අපි පාවිච්චිට ගන්නවා. Raspberry Pi එකත් අපිට උදාහරණයක් විදිහට ගන්න පුළුවන්. Okay, that's a good suggestion, right? I think you all know about the Raspberry Pi, right? So we can install a small operating system, right? And it work, right? So, but we need to consider about how we can insert a power source to work, right? So it's good, right? Your idea is really good. Any other questions? I had leader.
Oh, sir.
Okay. Then real-time operating systems are characterized by having time as a key parameter. Industrial process control system, real-time computers need to collect the data about the production process and use it to control machine in the factory, right? So there are real-time operating systems, right? Especially we are using in the industrial process control systems, right? There's a, now you know, in the industry, there are manufacturing lines, right? We need to monitor, right? Whether the certain conditions, right? Likewise, things are there. These are the Actually, we can say operating system soon, then type of operating systems. Any question, please ask.
Recording stopped.
Any question, please ask, right? Really good questions asked from me about how we can save file from a memory from the pen drive. Then another question came about the Raspberry Pi. Right? Good, right? These are good questions. If you have any question, please ask. Okay. So if you have time, right, you can install a VMware, right? Virtual machine in your computer, right? Then try to install Linux operating system, right? Then after that, you can work with the Linux environment and find out, right, how you can work with the Linux environment. Then if you have again further time, right, you can install another different type of operating system, maybe a server operating system, right? If you take Ubuntu server operating systems are there, Fedora operating systems are there, maybe Windows operating systems are there, different versions, right? Actually, you can first install a virtual machine, virtual box, then you can try, right? It's better, right? Then you can try several things, right? If you install a server operating system, you can do a lot of interesting things, right? You can actually install proxy servers, right? Then you can manage the DNS, domain name service, right? So you can actually write rules. If you have a proxy server, you can actually write several rules, right? You can restrict to access to the YouTube. You can restrict to access to the Facebook, right? Likewise, you can write several rules, right? Once you install the operating system, server operating system, you can find out it's easy to manage, right? So if you have time, please try, right? First install a virtual machine, right? Or virtual box. That inside the virtual machine or virtual box, you can install the operating system, right? Okay. So if you have any question asked, you didn't ask question, then I will go for the computer hardware review. A modern general purpose computer system consists of one or more CPUs and a number of device controllers connected to a common bus that provides access to the shared memory, right? Here, general purpose computer system consists of one or more CPUs, a number of device controllers connected to a common bus that provide access to the shared memory. Here you can see the CPU, here you can see the memory, here you can see the bus, here IO controller, IO device, right? Likewise, one or more CPU and number of devices controlled connected to a common bus.
Recording in progress.
Right. Then each device controller is in charge of specific type of device. For example, disk drives, audio devices, or video displays. The CPU and device controllers can execute in parallel, competing for memory cycles. To ensure orderly access to the shared memory, a memory controller synchronizes access to the memory. Right here, you see the memory. You can see the CPU, this controller. There are USB controller, maybe graphic adapters, right? Here you have this controller. Here you have mouse, keyboard, and printer. You have the USB controller. Here monitor, you have the graphical adapter. Then processors, right? If you take the brain of the computer is the CPU, right? Brain of the computer is the central processing unit. Fetch instruction from the memory and execute. Basic cycle of the CPU is to fetch the first instruction from memory, decode it to determine type and operands, execute it, and then fetch, decode, and execute subsequent instructions. Right? So you know there's a basic cycle of the CPU, right? If you first you need to fetch the instruction from the memory, then you need to decode it, right? Determine what type of instructions, then and operands, then execute it, then fetch, decode, and execute subsequent instructions until the program finishes this cycle carried out, right? The brain of the computer is the CPU, right? So what's happened? Fetch the instruction from the memory and execute. Then memory, right? Second major component in computer is memory, right? Here, the memory system is constructed as a hierarchy of layers. Top layer have high speed, small capacity, and greater cost per bit than the lower ones. Okay, right? So what's happened? You take the memory, right? Second major component in any computer is memory, right? Here the memory system is constructed as a hierarchy of layers, right? Here you can see register, then you can see cache, then main memory, then solid state disk, then magnetic disk, then optical disk, and magnetic tapes, right? Top layer have higher speed. You take these top layer registers have higher speed, but smaller capacity and greater cost per bit than the lower ones, right? If you take this register, have higher speed, right? Smaller capacity than main memory, right? If you take the main memory, have higher speed and smaller capacity than the optical disk. Likewise, right? When you are going for the top, right? Have higher speed, smaller capacity, and greater cost. Okay, I'm going to ask you a simple question. What is different between the solid state drive and hard disk drive? If you take a solid state drive, you can take a hard disk drive. What are the differences? Any answers?
Recording stopped.
Anyone? What are the differences between the hard disk drive and the solid state drive? Any answers? Okay. For homework, right, you can find out what are the difference between the solid state drive and hard disk drive. Let's move to the next
Recording in progress.
section. Registers, right? Top layer consists of registers internal to the CPU, made of the same material as the CPU and fast as CPU. Storage capacity available in then typically 32 into 32 bits for 32-bit CPU and 64 into 64 bit on 64-bit CPU. Program managed themselves in software and cache memory. If you take the cache memory, mostly controlled by the hardware, main memory divided up into cache lines, typically 64 bytes with address 0 to 63 in cache line 0 and address 64 to 127 in cache line. Most heavily used cache lines are kept in higher speed cache located inside or very close to the CPU. Like keep in mind, most heavily used, right? Cache lines are kept in high speed cache located inside or very close to the CPU. When program need to read a memory word, cache hardware check the line needed in the cache line. This is called cache hit, right? Sometimes you maybe heard this term cache hit. right? When program need to read memory word, cache hardware check the line needed in the cache. This is called cache hit. Caching is involved to improve the performance. For example, operating system use heavily use files to avoid fetch them from disk repeatedly. Then CPU have two types of caches. One is L1 cache, other one is L2 cache. If you take the L1 cache, always inside the CPU and usually feed decoded instructions into the CPU execution engine. Access to the L1 cache is without delay. Then L2 cache holds several megabytes of recently used memory words. L2 cache involves a delay of 1 or 2 clock cycles. Then general purpose computers run most of their programs from rewritable memory called main memory, or we can call random access memory. Main memory commonly is implemented in semiconductor technology called dynamic random access memory, right? Computer use other forms of memory as well, right? We already mentioned read-only memory and electrical erasable program read-only memory, right? There is ROM and EEPROM. Then I/O devices. If you take the input-output devices, generally consist of two parts. One is controller, other one is device itself, right? Controller here, chip or set of chips that physically control the device, right? Controller accept commands from the operating system. Then job of the controller is to present a simple interface to the operating system. Then device have fairly simple interfaces. They cannot do much and to make them stand, right? Controllers are different and different software is needed to control each one, right? Software that talks to the controller, given it commands and accepting response called device driver, right? Software that talks to the controller, right? Giving it commands and accepting responses is called device driver. Driver has to put it into the operating system so that it can run in kernel mode, right? So, any question asked, I'm going to switch between the slides slowly. You can read the slides. Any question, please ask.
Recording stopped.
Okay, we don't have questions. Let's start, right?
Recording in
Buses,
progress.
It's a communication system that transfers data between components inside a computer or between computers. Early computer buses were parallel electrical wires with multiple hardware connections, but the term is now used for any physical arrangement that provides the same logical function as a parallel electrical bus. There are two types of buses. One is internal bus, other one is external bus. Right? The internal bus, also known as internal data bus, memory bus, system bus, or front side bus, connects all the internal components of a computer, such as CPU and memory, to the motherboard. Then, internal data buses are also referred to as local buses because they are intended to connect to local devices. This bus typically rather quick and is independent of the rest of the computer operations. Then, if you take the external bus, or expansion bus is made up of electronic pathways that connect the different external devices, right? So buses have two types, right? Internal bus or external bus, right? In the internal bus, what's happened? All the internal components of a computer, right? Like CPU, memory, to the motherboard, right? Okay, then are connected. But if you take the external bus, it's different. The external bus or expansion bus is made up of the electronic pathways that connected the different external devices. Then booting the computer. When computer is booted, the BIOS is started. First check to see how much of RAM is installed and basic devices are installed and responding correctly. Then process start by scanning the ISA and PCI bus to detect, right, all the devices attached to them. These devices are typically legacy and have fixed interrupt levels and IO addresses. Then BIOS determine the boot device by trying the list of devices stored in the CMOS memory, right? Once it has all device drivers, OS load them into the kernel, then initialize tables, create whatever background process and start up loading program, right? So I think this is all about the today's lecture, right? This is the reference, right? So any question, please ask. For summary, right, we talk about the operating system, then goals, right, then functionalities, right, then we discuss about the type of operating systems, right, there are different type of operating systems. Finally, we talk about the computer hardware. Actually, it's a review about the computer hardware, right? So this is all about the introduction to the operating systems, right? So if you don't have the questions, then we will wind up the session.
Excuse me, sir.
Yes, ask.
Sir, Linux කියන්නේ OS එකක්ද kernel
Recording
එකක්ද?
stopped.
Linux කියන්නේ operating system එක. Kernel ඇත්තටම අපිට kernel කියන concept එක තියෙනවා. Kernel කියලා කියන්නත් පුළුවන්. Linux කියන්නේ operating system එකක්. සමහරවිට ඔයාලා confuse වෙනවා ඇති Linux kernel කියලා අපි හඳුන්වනවා. ඇත්තටම මේ Linux වල එක වැඩ කරන එක බොහොම වටින දෙයක්, right? මොකද Linux වගේ දේවල් එක්ක familiar වෙන්න පුළුවන්. Linux එක product benefits, right? If you are working with the Linux, there are a lot of benefits, right? Easy to install, especially it's really easy to install the softwares, right? So first, please check, right? Please install a virtual machine, right? VMware is there, virtual boxes are there. Then try to install Linux. Then try to install separate OSs like server OSs, right? So I'm giving you another 1 or 2 minutes. If you have any question, please ask.
එතකොට සර් දැන් මේ Google එකේ දැන් Linux download කියලා ගහපුවාම මේ OS ටිකක් දෙනවා. ඒකේ සර් මේ Linux site එකේ තියෙන්නේ Ubuntu මේ කාලී වගේ ඒවා තියෙන්නේ. Linux කියලා OS එකක් නැහැ. දැන් එතකොට MCQ
නෑ
ගහලා තිබ්බොත් අපි මොකක්ද දෙන්නේ Linux
නෑ දැන් අපි ගත්තොත් Windows කියලා ගත්තොත් Windows අපි කියනවා 10 නේ Windows අපි කියනවා 11 right ඒ වගේ Linux තියෙනවා Linux වල තියෙනවා එක එක versions දැන් ගත්තොත් Fedora තියෙනවා දැන් ඊට පස්සේ ගත්තොත් ආයෙ තියෙනවා Ubuntu තියෙනවා right ඊට පස්සේ ඔයාලා ගත්තොත් ඔය ගොඩක් certifications එහෙම තියෙනවා දැකලා ඇති Red Hat වගේ ඒවා තියෙනවා right ඒ වගේ different දේවල් තියෙනවා right ඔය කියන එක හරි Linux කියන එක OS එක Linux kernel කියලා කියන්නත් පුළුවන්. ඒකේ ගොඩක් operating systems තියෙනවා right. උදාහරණයක් විදිහට අපි ගත්තොත් Ubuntu තියෙනවා. ඊළඟට Ubuntu කියයි, Xubuntu කියයි. ඒ වගේ ගොඩාක් OSs තියෙනවා. ඔයාලට ඕන එකක් පාවිච්චි කරන්න පුළුවන්. දැන් ඇත්තට ගත්තොත් Android ගත්තොත් Android පවා අයිති වෙන්නේ Linux වලට. පැහැදිලිද?
ඔව් සර්.
තව ප්‍රශ්න තියෙනවා නම් අහන්න. දැන් අපි කියන්නේ Windows operating system එකක් කිව්වට අපි එහෙම නැහැ Windows කියලා එකක් නැහැ. ඒක Windows තියෙනවා Windows 10 Windows 11 ඒ වගේ. ඒ වගේ තමයි Linux. Linux කියන්නේ kernel එක වගේ එක හරියි. ඒක තමයි Linux වල වර්ග තියෙනවා. Ubuntu තියෙනවා. ඒ වගේ තියෙනවා. තව ප්‍රශ්න තියෙනවා නම් අහන්න. තමන් ඔයාලට විනාඩියක් වගේ කාලයක් දෙන්න. ප්‍රශ්න තියෙනවා නම් අහන්න. Windows edit කරන්න පුළුවන්ද කියලා අහන කෝඩ් එකක් කරා Windows එක කොහොමත් එයාලගේ Windows වලදී තියෙන්නේ අපි පර්චේස් කරන්න ඕනේ. ඒකට ඒ කෝඩ් එකක් edit කරන්න අමාරුයි. ඒ වුණාට Linux වගේ platform එකක තියෙන මේ OS එකක් ගත්තොත් ඔයාලට edit කරන්න පුළුවන්. Windows එක කොහොමත් එයාලගේ කෝඩ් එක දෙනවා එළියට දෙනවා. But if you take the Linux then you can do the edit. I need to do another announcement, right? Next week, Monday, you don't have the operating system lecture, right? I will inform you the date, right? Date and time. Any questions?
සර් දැන් අපි Arduino වගේ එකක් ගත්තොත් ඒකේ සර් අපි මේ C වලින් කෝඩ් කරන එකනේ කරන්නේ. ඒකේ සර් එතකොට ඒකෙත් OS එකක් තියෙනවා.
ඒකේ Arduinoද?
ඔව් සර්.
අපි ගත්තොත් Raspberry Pi ගත්තොත් අපිට Raspberry Pi වල OS එකක් තියෙනවා. right? Arduino වගේ ගත්තොත් Arduino වල predefined functions තියෙනවා. අපි කරන්නේ code හරහා ඒ predefined functions වලට call කරන එක.
එතකොට ඒක අයිති වෙන සර් embedded system වලට.
ඔව් ඒක අපි ගත්තොත් Arduino embedded වලට අයිති වෙනවා. අපි ගත්තොත් Raspberry Pi ඊට පස්සේ Orange Pi වල අහලා ඇති. ඒ වගේ ඒවට අපිට කෙලින්ම operating system එකක් install කරලා memory card එකක් දාලා අපිට use කරන්න පුළුවන්. හැබැයි අපි Arduino වලට memory card එකක් install කරලා use කරන්නේ නැහැ නේ. Arduino board එකේ predefined functions තියෙනවා. මේ දේවල් කරන්න පුළුවන්. එතකොට අපි ගත්තොත් Raspberry Pi Orange Pi ගත්තොත් ඒවා single board computers විදිහට තමයි අයිති වෙන්නේ. අපි සරලව කියනවා single board computers කියලා.
එතකොට සර් මේ අර සෙන්සර් නෝඩ් මේ සිස්ටම් හදනකොට මේ Arduino ගන්න මොනවද?
I can Arduino අපිට පාවිච්චි කරන්න පුළුවන්. අපිට එහෙනම් Arduino තව මොකක් හරි device එකක් එක්ක connect කරලා අවශ්‍ය නම් පාවිච්චි කරන්න පුළුවන්. ඔයා අහලා තියෙනවද PCB design කියලා? Then when we are actually in the industry, right? Actually, we can do the PCB designs, right? We can design. We have several microcontrollers, right? We can program the microcontrollers. We can attach several sensors, and we can actually design. Yes, we can use Arduino, Raspberry Pi, each and everything as embedded devices. But you need to understand, right? What are the advantages and disadvantages? විශේෂයෙන්ම අපි ගොඩක් ඔය ගැන කතා කරනවා අපිට third year එකේ subject එකක් තියෙනවා IoT Internet of Things and Embedded Systems කියලා. ඒ subject වලදී අපි කතා කරනවා embedded system එක කියන්නේ මොකක්ද? ඒකේ තියෙන embedded system වර්ග මොනවද? ඊට පස්සේ එතනදී අපි deeply කතා කරනවා කොයි විදිහට ගන්න පුළුවන් කියලා.
Okay.
ඊට පස්සේ තව subject එකක් තියෙනවා Internet of Things කියලා. ඒකෙදී අපි කතා කරනවා කොහොමද මේ හැම දෙයක්ම connect කරන්නේ කියලා. For an example, if you have Raspberry Pi, then if you have Arduino board, then there is a server, right? There are several sensors, right? What are the architectures we are using to connecting these things? How we can connect it, right? Likewise, we can talk in those subjects, right? Actually, we are asking good questions, right? Because a lot of people confuse, right, about Android. Actually, we can have an operating system in the Android, or we can have an operating system on the Raspberry Pi, right? So in your lab, right, in our ICT lab, right, we have a lot of, we have actually Arduino boards, we have Raspberry Pi boards, we have boards like that. Then we have 3D printers. Then we have different type of sensors, right? In our ICT lab, we have facilities and we have kits, right? Like small vehicle kits, right? Likewise, small robotic vehicle kits, right? Likewise, we have several resources in our lab, right? Even though we have all the resources, we have resources, right? My PCB kits, right? I told you about PCB designs. We have PCB kits, right? Likewise, in our lab, we have resources are there. If you take network inside, we have routers, we have switches, we have connectors, we have cables, everything is in the lab, right? So actually I will do small workshop, right, for you about the Arduino, then Raspberry Pi and different sensors, right? When we are doing the embedded system and IoT, we have to do the practicals with those devices for you, but one day I will do a small workshop. Okay, if you don't have any questions, then I will wind up the session, right?
Okay, sir. Thank you.
Okay, then
Recording
thank
in
you for
progress.
participating to today's lecture, and have a nice day.
Thank you, sir.
Record.